Let's talk about math, numbers, and random numbers in MaxMSP. The first thing to be aware of is that there are two types of numbers. You have integers, or ints, and floating point decimals, or floats. And they're very, very different. Here is an int. I can create that by hitting the letter I on my keyboard. And here is a float, which I can create by hitting F on my keyboard. They both come up as a number box. I can move them around. I can lock the patch and increase or decrease to an infinite level. I can initialize them back to 0. The difference is that with the float, I can also have decimals. And that decimal point after the 0 is the key. That is how you tell that something is a floating point decimal number in Max. And this is really, really important because if I were to send an int to a float, it's no big deal. Whole numbers translate to whole numbers with the decimal point. But if I send a float to an int, watch what happens. It truncates the decimal. It removes it. So I have the whole number 0, but none of the decimal points. And it won't even show up until I go to 1 on the whole number and then above. And then still it's removing every decimal place after that. This can be really, really useful and really, really annoying depending on what you're trying to do. Sometimes it can be really great and it can help because you don't really care about the decimals and you just want to know if it hits that perfect whole number threshold. And sometimes the decimals are going to be really important. So be aware of what type you're using at all times, whether it's int or float. That said, you have to know when you're creating objects as well what you're going to use. For example, let's use one of the most common operators here, plus. I'm just going to add two numbers together. I can give it an argument. We're just going to say +2, and I'm going to send it out to a message so we can view the result. Let's hook up the floating point number to it and see what happens. Take it back down to 0, so we should get 2. Now as I increase the whole number, it's exactly what we expect. 4 plus 2 equals 6. As I increase the decimal, however, note that nothing happens. It still is only outputting the whole number. This is because in Max, anytime you're dealing with floats, you have to initialize the object by giving it a decimal point. So if we change this to +2 decimal point, and then increase it, now it's outputting a floating point number. So very important concept. If you want to do this, but you want to use the right inlet to change the argument value, there's an easy trick that a lot of people do, which is to initialize with 0 point. So this will just pass through whatever I've got, but then I can set another float here into the right inlet, and we'll give it about 3.14, and it will add those two floating point decimal numbers together. If I have an int hooked up, and I'm sending an integer, and I'm adding it to a floating point, well, watch what happens. Because this plus object has been initialized with a decimal, with that 0 decimal point as the argument, it is still going to output a floating point value. So it will take this floating point, 3.14, that I've fed into the right inlet, and it will take the integer 4, and it will add them together and output a floating point decimal. Very, very important. Now, for math that you're going to want to do in Max, there are a number of very common operators. In addition to plus, we have minus, which again you would have to initialize with a 0 point. We have a couple others. Multiply. Again, it's good to initialize. Of course, there is divide. However, in this case, I don't recommend initializing it with a 0 point because then you'll get divide by 0 errors. I recommend doing 1 point here. And all of these can output exactly as you would expect. So let's set some messages and take a look. So let's do 2 and 4. So 4 plus 2 is 6 with a decimal point. 4 minus 2 is 2. 4 times 2 is 8. 4 divided by 2 is 2. Okay, that's cool. What if we try something a little crazy, like 15? Well, here we get some interesting results. Because we're using decimal points, our divide is giving us 7.5, which is exactly half of 15. Everything else is going to be a whole number without any decimals, even though they have the decimal point after that, because 15 and 2 are both whole numbers. So, very important. But what if I change 2? Let's do 2.75. And 15 again. I have to reinitialize it. Oh, there's all our decimal points. I can stretch that out. So again, be very wary of the type that you're using, and make sure that if you're using decimals that you initialize your math objects with a decimal. Note about the divide operator. Be wary of it because it tends to result in unintentional divide by 0 errors, which you probably don't want. So 15 divided by 0 equals infinity. Bad. So how do we avoid that? Well, the most common way is to use the multiplication object instead and reciprocal identities. What that means is that if, for example, I wanted to divide something by 2, so divide by 2. Instead, what I can do is I can take the number 1, divide that by 2, and I'll get 0.5. If I multiply something by 0.5, it's exactly the same as dividing by 2, but it's a little bit safer, and I can usually avoid those divide by 0 errors. There are some other mathematical operators to be aware of. Ones that you'll probably want to use in music are going to be pow and square root. Pow is really pretty cool. You take two numbers and you raise the number coming into the left inlet to the power of the number coming in on the right inlet. I'm going to use integers here just so we have whole numbers to work with. It makes the math a little easier to do in my head if I have to double check. But again, you can do decimals. So let's raise something to the power of 2. And let's do 7 to the power of 2. That gives us 49. That is correct. Now, I can also give pow an argument of 1 decimal point, and 7 raised to the power of 1 is 7. Great. But if I change this to a floating point number, let's see what happens with 7.12. And then let's raise that to the power of 2 instead and do 7.12 again. Little bit over 50.69. Interesting. So again, it can be initialized using a decimal point. Anything raised to the power of 1 is itself. It's an identity function, so I recommend using that as opposed to a 0 point. The opposite of this is SQRT, or square root. This always takes the square root of whatever is coming in. So let's use an integer. And let's try 36. And we get 6. It's exactly what we expected. But let's try it with a float. How about 122.45? Let's try that. And we get 11.065713. Now, you'll notice I didn't initialize this with any type of 0 point or 1 point. This is kind of the exception object. It will take whatever you give it, and it will always output a float. It just assumes that you're going to want a float. Very powerful, very useful thing to have. But that might not be enough. What if you want to chain together things into a longer equation? Well, fortunately, there's a really, really powerful object called expression, or EXPR. And this evaluates a mathematical expression, very similar to the C language. In order to use that, you need to have variables. And we can ignore the error here for a second. Variables are always going to show up with a $sign. For expression, they're going to be of a specific type, so either $I or $F. I is for int, and F is for float. Then you have to give them a number. Expression can only take 9 variables at a time, so you can do $I 1 through $I9. You could do $F1 through $F9, or some combination thereof, where you're mixing ints and floats. Now, this is also important because the number that you give it will also create inlets from the left to the right. So let's try this with a really basic one. I'm just going to add 2 to whatever comes in, and let's do a float. So we'll take the output here, and we'll give it a float, and we get everything plus 2. So 0.81 plus 2 is 2.81. Now, if I change this, let's make this $F2. You'll note that it's created a second inlet right here, and that it is a cold inlet. So I'm going to create another float box, and we'll add that together. So let's do 0.28 or 0.028 plus that. Very cool. We're adding those 2 decimals together and outputting it. Of course, if I give it an integer instead of a decimal, it treats that integer as if it were a decimal. However, if I give it a decimal instead of an integer that it's expecting in the expression, then it will truncate the decimals and only take the whole number. So be wary of that. Let's look at a more advanced usage of how expression can work. If you're going to use square roots, or if you're going to use a POW to raise something to the power in there, you have to be very careful with how you're doing it. with POW, let's just clear this out. What you have to do is give it the variable that you want to raise, or a parentheses with a smaller expression inside of it, then a comma, then the value you want to raise it to. So let's do $F1 plus 2 to the power of 2 plus $F2. Oh, illegal comma. It's telling me I have an illegal comma because I did not include the open parentheses. You do have to be wary of that. Okay. So what this should do is it should take whatever's coming in from the first number box, which in this case will be a whole number, add 2, raise it to the power of 2, and then add whatever's coming into the second. So let's try this really easy. Let's just do 0.5. So we're going to have 0.5 added to whatever's in here. If we do 7, 7 plus 2 is going to be 9. Raised to the power of 2 is 81. So this should be 81.5 if I input 7. And indeed, that's exactly what it is. Now, working with square roots is going to be very similar. So you can only take a single number inside the square root. And then we'll add the two together. So let's do 81 plus 0.5. Because I changed it, I'm going to reinitialize the 0.5. And let's do 81, so we should get 9.5. Ta-da! Basic math. So very, very useful thing to have. But there's a lot of stuff available on Expression. I really recommend for this one that you check out the help file and the reference, and definitely go online and see what people do with it, because there's just so many options that are available for it. There are two other things that you should be aware of when you're going to be working with numbers. There are things that you're going to want to use where you're going to get the maximum or the greater of two values. But this is not going to be a simple greater than or less than sign. Instead, you're going to use maximum, and if you want the lesser of two values, you're going to use minimum. And they operate exactly the same way. So let's start with maximum, and then do minimum over here. I'm going to create two ints and connect them up so that we can see the resulting numbers. Add a couple of messages. And here we go. Okay, so we'll give it the initial here. So this is going to be 7. Now, as I drag the number up here, on the maximum, it will output whichever number is bigger. On the minimum, it will output whatever number is smaller. So here, if I have 1, it's got 7 coming in to the cold inlet and setting the argument. So 7 is clearly bigger than 1, so it outputs 7. Over here, 7 is the argument, but it's receiving 1, and 1 is definitely less than 7, so it's outputting 1. As we increase it, until we get to 7, it is always outputting the lower number from minimum and the higher number from maximum, which was 7 in that case. But now as we go above it, maximum is always reporting the higher number that we're testing from the left inlet, and minimum is still reporting 7 because that's lower than 16. So it's a very useful tool to have for logical tests. Another one that's very useful, and that I personally get a lot of mileage out of, is ABS, or absolute value. This is the simplest one to discuss because here's what it does. I'll just create a message. I'll give it a value of -27, connect it up, and then take the output of ABS. All it does is it flips a negative number to a positive number. Now, of course, you can do this with floats as well. If I give it the format 0 point, and then I make this -27.376, we get a float. I should mention you can do the same thing with maximum and minimum. You would just give it an initial value of 0 point and 0 point, and then set your value. And you can see now that they're outputting decimal numbers, even though I'm using an integer. We can change that pretty easily by creating a float, connecting those up to the float, deleting that. Decimal output. Okay, so that's pretty useful. Let's look at probably the most understood, or misunderstood, I should say, object for math. And that is the percentage, which is also known as module, or modulo. What this does is it takes an inlet from whatever's on the left, and it divides it by the argument or whatever you set in the right. Then it outputs the remainder of that division. So let's do this with 12, modulo 12. If I put an int there, you can see as I increase this, when I get to 12, I get 0 for my remainder. Then as I go over, number increases until I get to 24, which is a divisor of 12, or 12 is a divisor of 24, I should say. And so I get another 0. At 36, I'm going to get another 0. At 48, I'm going to get another 0. This is great. This is not immediately obvious, but if you want to do anything with retuning, with set theory, with 12-tone transpositions, changing a keyboard into something other than 12 tones per octave, this is an essential object when paired with the divide object, because then you'll get something like the octave and the pitch class, and then you can use that and transpose it how you will. It's very, very useful. Again, make sure that you initialize it with a decimal point if you want decimal output for floats, or leave the decimal off if you just want it to be integers. So that's really, really useful, but I can hear what you're saying. What if I want something a little bit more random? What if I want the computer to just generate numbers for me? Well, there are a number of ways to do this, but there's a couple that are the most common. All of these can use random seeds, which will give you a specific pseudo-random sequence every single time as long as it's the same seed. But the way in which you set that random seed is slightly different in each case. We'll start with the easiest one, which is decide. Decide takes a bang as its inlet, and as its output, it gives you one of two things. It gives you a 1 or a 0 at random every time you click it. It's just a coin flip. That's all it's doing. Now, on its right inlet, however, you can set a random seed. If you don't have anything there, it's using your system clock, which is the default for all randomness in Macs, but giving a specific random seed can be very useful if you discover a cool sequence using random seeds and you want to replicate it on patches that you give out to other people. So to do that, you just create an int and hook it up. Specify the seed you want to use. I don't even know what that is, but we'll click it. And it's got our random seed. Now, that's pretty useful, but in order to get a good value range, you'd have to do some stuff with math and create an expression and multiply it and scale it and do all that stuff. There's got to be a better way to get some other numbers. And in fact, there is. The most common way to do random numbers is with random. Now, random takes two arguments. The first is the range limit, which is an integer, and the second is the random seed. So we'll give it a range of 5. And I'm not going to touch the seed yet. You can initialize it that way, but there's another way to do it that I'll show you. And we give it a bang, and we take a look at the output. Random will output any value from 0 to 1 less than the range argument. So if I have a range limit of 5, it will output 0 to 4. So 0, where's my 4? There's my 4. But no matter how many times I click it, I will not get 5. So anytime you use random, it's always 1 less than the number specified. And if you want to have it go up to that number, just add 1 when you're creating the random object. Now, the right inlet on random is not for setting the seed. In fact, that is for setting the upper limit. So if I change this to 6, we start getting 5s. We get 0 up to 5. To change the seed, I have to send a message. I give it the message seed, and then I give it the value. That gets connected to the left inlet. If I click that, it tells it to use that specific seed. Pretty cool. Now, the other one that I like especially if I want a little bit more structure in my randomness is the earn object. And this is similar to taking balls out of a jar or an urn. When you take a ball out, you remove its values. So you can't have that value show up again. So if you take the 7 ball out, then that's been used up. You'll never draw another 7 until you refill the urn. And that's exactly how this works. So we'll create it, and we can give it a limit, which is our range, and we can give it an argument for the seed, just the same as random. As with random, it's going to output 0 to 1 less than our limit, and it does that every time we bang it. Now you'll notice that this has 2 outlets. That's a little interesting. Let's take a look at what happens with that. I've got the outlet, which is going to be the number, and then the second outlet is going to bang if all the numbers in the range have been chosen. So I'm going to put a bang there, and we can hook that up. So this should give us 0 to 5, or 0 to 4, sorry, because I gave it an argument of 5. So 1, 2, 3, 4, and last one. And now it's going to bang because I've used up all the values in the urn. So to fix that, I have to create a message of clear, spelled correctly, and send that to the left inlet of urn. Now I can use it again. As with random, I can also change the upper limit by connecting an integer to earn on the right inlet. Now you'll note that this is a hot inlet. Why is that? Well, because it resets the count. It resets the number of objects that are in there. So there we go. We can get a 5 now. That's important to know, that if you change the number here for the range, it will also reset the values that are in there. As with random, I can seed it with a message. Seed, and then I just give it the value. And in doing that, cool. It works. So these are just the most common ways to use mathematical operators to do expressions and to do random numbers. There's others as well. You might want to explore things like the drunk object to get drunk in motion. And there are many, many, many more things that you can do with expression. So check the references and have fun with those.